sounds from the ocean that scientists couldn't explain. A Dark Depths documentary. In 1997, the ocean made a sound so loud it was heard across an entire ocean basin. No one knew what caused it. The deep ocean is not silent. It never has been. Beneath the surface, the planet constantly produces sounds, some natural, some biological, and some so powerful that scientists initially feared something catastrophic had occurred. In this Dark Depths documentary, we explore real ocean sounds that scientists couldn't immediately explain what recorded them, what theories emerged, and why some of these sounds still feel unsettling today. And around 70% into this story, we'll reach the sound that was once so mysterious that it sparked speculation ranging from unknown creatures to events capable of reshaping the planet itself. If real ocean mysteries and true scientific investigations pull you in, subscribe to Dark Depths. These sounds were actually recorded. The ocean is never silent. Most people imagine the deep ocean as quiet, dark, still, empty. In reality, the ocean is one of the noisiest environments on Earth. Water carries sound 5 times faster than air. Low-frequency sounds can travel thousands of kilometers without losing strength. The ocean constantly echoes with shifting tectonic plates, ice cracking and collapsing, volcanic activity, marine life, communicating across vast distances. To human ears, most of this is inaudible. But to scientific instruments, the ocean is always speaking. Most people miss this. Silence in the ocean doesn't exist. Only sounds we haven't learned to recognize. And in the 1990s, scientists started listening more closely than ever before. Why scientists were listening in the first place during the Cold War. The world's oceans were filled with listening devices, not for science but for submarines. The U.S. Navy deployed a network of underwater microphones called hydrophones, designed to detect submarine movement, explosions, nuclear tests. When the Cold War ended, many of these systems were repurposed. Suddenly, scientists had access to an unprecedented ability to listen to the entire ocean. What they heard wasn't what they expected. Most people miss this. These systems weren't designed to find mysteries. They found them anyway. And then, in 1997, one sound stood out above everything else. The sound that shook the Pacific. In the summer of 1997, hydrophones detected an extremely loud, ultra-low frequency sound in the Pacific Ocean. It lasted over a minute. It was detected by sensors more than 5,000 kilometers apart. The sound was nicknamed the bloop. At first, scientists didn't know what it was. Its volume suggested something enormous. Its frequency suggested a biological source. Its reach suggested unprecedented power. Speculation exploded. Some suggested unknown marine animals, massive underwater events, phenomenon never before recorded. For a brief moment, science didn't have an answer. Most people miss this. The bloop wasn't frightening because it was loud. It was frightening because nothing known should have been able to make it. If you heard a sound that powerful, would you want to know what caused it? But the bloop wasn't the only unexplained sound. Other ocean sounds that raised alarms. As scientists reviewed years of recordings, patterns emerged. There were many unexplained sounds, long, slow moans, rising tones that lasted months, rhythmic pulses with no clear source. Some were named for convenience: Julia, upsweep, slow down. Each had unique characteristics. Some repeated for years, some disappeared suddenly, some changed pitch over time. Scientists worked methodically, comparing seismic data, checking ice movement, analyzing volcanic activity, but explanations didn't always come quickly. Most people miss this. The ocean doesn't produce single mysteries. It produces entire catalogs of them. Eventually, some answers began to emerge, but they weren't comforting. The explanations that changed the fear. Over time, scientists identified many of these sounds as natural processes. The bloop, for example, was eventually linked to ice quakes, massive ice fractures caused by glaciers breaking apart. Upsweep was tied to volcanic activity along mid-ocean ridges. Julia was linked to underwater seismic events. These explanations were logical, scientific, and unsettling in their own way, because they revealed something else. Most people miss this. The ocean doesn't need creatures to be terrifying. The planet itself is loud enough. If you want more true stories where science slowly catches up to the unknown, subscribe to Dark Depths. This is how mysteries actually unfold. Why some sounds still feel unsettling. Even with explanations, these sounds remain disturbing. Why? Because of scale. Ice cracking loud enough to cross oceans. Volcanic activity hidden beneath kilometers of water. Tectonic plates shifting silently until they don't. These sounds remind us that most of Earth's activity happens out of sight. Humans are observers, not controllers. The ocean doesn't announce itself for us. Most people miss this. We didn't discover these sounds. We overheard them. What scientists learned from listening changed ocean science. It revealed how dynamic the deep ocean really is, how connected Earth's systems are, how much happens without human awareness. The ocean wasn't hiding secrets. We simply weren't listening properly. The ocean didn't produce sounds to scare us. It produced them because the planet is alive, moving, breaking, reshaping itself constantly. The mystery wasn't the noise. The mystery was our silence. In the next video, we'll explore deep-sea cameras that recorded something watching back. Watch that next. Because the ocean doesn't just speak. Sometimes, it listens too.